This is Frank from Laytool. I'm very happy to show you our front-end SDK PWCore. This is a library writing in TypeScript, so it will be very easy for you to integrate this SDK into your front-end project, such as Vue project, and the React projects. And today we are going to walk you through the programming procedure with a Simplest-Dapp. We will see the Dapp later. And first, let's introduce the highlights of PWCore. It is an easy to use Jest library for CKB Dapp developers, and especially for the front-end developers, because we have some the grammar candies for you to use. So then first we provide a simplified programming model. In the PWCore procedure, you first decide a provider, such like ETH provider, which will get you the address of the current wallet. Of course, if we support more wallets, support more blockchains, you also have EOS provider, Tron provider, library provider, etc. Whatever, right? You can also customize your own provider, such like a burner wallet provider, which means you can write a provider to generate a CKB account inside a browser with the JavaScript, right? So once you decide your provider, you can come to build your transactions. And when you're building your transactions, you may need to fetch and spend sales from the server or from indexer. So we just standardize this procedure with the collector. And when you build a transaction, you will need to sign the transactions, right? So if you are using a ETH signer, which we'll call the ETH, the Web3 async function, it will invoke the MetaMask or other Ethereum wallets to sign your transactions. And if you want to customize the hash algorithm, you can also provide your own hasher, just like we already provided the Blake2B hasher and a Kashak 256 hasher. And the second one is we recommend to build sales instead of compose transactions directly, which means in your mind, when you want to just like deposit and never stop, instead of just what's the structure of the transaction, we recommend you to think like what's the output sales we are going to build. If it is a debit sale, you need to provide the lock of the user from the address, right? The lock script. And you need to provide the TypeScript of the never style. And you need to provide the capacity. And you also need to fill the data field with the 8 zeros, if I'm right. Yeah, it's zeros. So once you decided your output sales, you can use the collector to get your input sales, and then the transaction will be assembled automatically without any extra work. Yeah. And the second point is we designed a lot of considerate models. I recommend you to read the README from the GitHub repo, which is here. Yeah, you can see this is the README. This is our repo, GitHub, Laytool PWCore. And the README has a lot of more content than my PPT. So if you are going to use the PWCore, I strongly recommend you to read through this README. And if you have time, read the source code of the models, so you can discover a lot of tools and tricks inside the models, which will save you a lot of time. So let's show you some interesting part. The first one is our model address. As we know, PWCore can use the Ethereum wallet and the Ethereum address as CKP address, right? So when you want to actually use an Ethereum address, how would you, transform the address into a log script? So you just need to new address instance and pass the Ethereum address as the first argument. And this is a comma. Yeah, this is a typo. Sorry, this should be a comma. And then you pass the address type as the second argument. So you get ready. You are ready to get the address object. If you want to check the address, if the address is valid, you just invoke the valid method. And if you want log script, just call the toLogScript method. And if you want the log script hash, you just call the toHash method on a script instance. This is the same with the TypeScript. And second, we want to show you the amount class. As we know, the amount in CKB is complicated. Sometimes they are hex numbers, sometimes they are decimal numbers, and sometimes they represent Shannon, and sometimes represent CKB. So with amount class, you don't have to worry about the big number, the unit, the format. You just new this amount with a hex number and pass the amount unit Shannon as the second number. So this represents the amount of Shannon. We will get amount representing 208515553 Shannon, which is 0.2851553 CKB. And the second amount is just a 1000 CKB amount. If you omit the amount unit, it will the default unit will be CKB. Then let's get some calculation. We just use e1.add a2 to get the sum of the two amounts. And if we want to get it displayed in some complicated format, we just use toString. With the first argument, we can decide the unit of the amount. And with the second option object, we can adjust the more advanced formats, such like comify and fixed. As we know, the sum will be 1000.208515553, right? So if we got the fixed to 5, we have to 1000.20851. But the sixth digit is 5, and we should get it into, we should change this one into 2, right? So the final result will be 1000 with a comma here and 0.20852. There are more options here, such like pad. You can add padding zeros at the end, and you can choose which part of the number you want. You can pass the, let's say, the code. Yeah, you can see here section. Yeah, you can pass the section as 4. 4 means this is the whole number, with the whole and with the fraction. And you can also just pick the whole part or the fraction part. And the third one, and the most important one, is that if your Dapp integrates PWCore, your Dapp can run in Ethereum wallets, both desktop, which is MetaMask, and mobile, which is IM token, Trust Wallet, Alpha Wallet, etc. This is the only way that you can get your dApp running inside your smartphones. So if you want, to build a mobile dApp, at least it can be run on the phone, PWCore will be your only choice currently. Okay, so today we are going to walk through the Simplest-Dapp. The Simplest-Dapp, we've got a live demo here, which is SD Simplest-Dapp.lay2.dev. And this is, the dApp looks like this. You can see this is a very simple dApp. First, you can see the testnet address, which is converted from the currently ETH address. You can see the capacities. The free capacity means the data is null, and the used one means the data has some text here. You can see it's a 72 CKB cell here, and the total means the sum of the two values. Okay, it's very simple that. So user can store text in cell data and view or manipulate them on the page. And we got some detailed features. First, we have to use the Ethereum wallet. And the second one, we are going to display some info like address and the capacity. The third one, we have some operations for the cells. We can create cells, we can delete them, and we can also update them. And there are extra regulations here. First, for the data input, we can accept both plain text and hex string. Let's say that when we create cell, we can see that both ASIC string and hex string are supported. Yeah, and for the second one, we want to use as small capacity as possible. This relates to a function in our cell model, which is called resize. We will see this in the code. Okay, first step, let's get some initialized work for the PWCore environment. The initialize is very simple. Let's see the actual code here. So in the mounting method, we use the await new PWCore. This is the node address of the Agrarian testnet. Yeah, this is from our server. If you've got your own full node URL, you can just fill them here. And then you call the init method with two required arguments. The first one is the provider, and we are using the ETH provider. And the second one is the collector. We are building our customized collector for this step. So this is called SDCollector, Simplest-Dapp collector. Yeah. And for the mainnet and the testnet, this is enough. But if you want to use your own DivNet, there are two extra arguments to pass in. First, you have to change this URL to your testnet, to your div chain URL, and then you will have to add the chain ID. This is the enum, and you have to point it to CKB div. And you also need to compose your own specs, chain specs. What is chain specs? We can see that there are three built-in specs. First is Lena, and the second is Agrarian. They are constant, so they won't change. And the third one is our DivNet spec. You can see the spec mainly contains the door type, the default lock, the multi-sig lock, and the PW lock. The PW lock is the lock script of our of the PWCK. So because if you are using your own dev chain, the cell depths may change, and the script may change, so you have to provide your own version here. And also, you can notice that we prepared the multi-sig lock. So this means PWCore is the only infrastructure that supports transaction to multi-sig locks address. If you are going to send some CKB to a multi-sig lock address, the only way you can achieve this now is use our Portal wallet, which is also adapt built with PWCore. You cannot do this with Neuron because Neuron haven't support the multi-sig address other than that. Okay, let's just take this back. So after you initialize the PWCore, you got three functions. The first one is send. You can just send CKB to some address, very simple with this method. It takes three arguments. The first two is the address and account, and the third one is the optional, which is the favorite. And if you are going to build a more complex transactions, you can use this one, send transaction. The first argument will be a transaction or a builder. So if you already have a build transaction, you can just put the transaction object here, and you can also put the builder here. The second one is signer, which defines the signer you want to use, and third one is the favorite. And also, if the built-in methods cannot meet your need, you can just directly use the IPC interface with the node here. For example, you can get blockchain info here to determine whether which blockchain, what is the chain ID you are using. Okay, for the provider helps access the account info, mainly the address, of the crypto environment. And the built-in ETH provider can enable most mainstream ETH wallets. And you can also access the provider as the PWCore.provider. This is the static member of the class. And for the collector, as we noticed, they are all virtual classes, so you cannot get an instance directly from it. You have to extend it and build your own class, your own collector, your own provider. The collector helps get balance and unspent cells of the specific address. And as we all know, the CKB is an UTXO blockchain, so you will always need an indexer or a cache server as the backend service. And you can also access the collector from this member, a static member. So let's go to the second step to retrieve the account info. We already see that here, after we init the PWCore, we can get the address directly from the provider, right? PWCore.provider.address. And this is an address object. We noticed that we used a function called toCKBAddress because this address is an ETH address. So if you want to get the CKB format of the ETH address, you just use this function. But what if we want to get the original ETH address string? You can just directly call the address string attribute instead of using the toCKB address. Sorry. Okay. So for the and we also need to get to the capacity. So we use our SDCollector. We need three capacities. The first one is the total capacity. We just use get balance. The second one we have to fetch the occupied capacity. We define an option object that calls this data. Yeah, if we set this to true, we can fetch the cells with data, and if set this false, we can fetch the cells without it. Yeah, and let's see this collector. The collector is very simple. Yeah, basically you have to realize two functions. The first one is the get balance, and second one is collect. You can use the recommended arguments here, and also you can just define your own arguments yourself. Let's go to the code. First, we use the CKB indexer. You can see this in the SDCollector. The index URL is this. This is an agrarian indexer. And the second one, the get balance function is to calculate the capacity of all cells. It is very simple because we extract the cell fetching functions as a get cell function. So the get balance is just first get the cells and to see if the cell array is empty. If it is empty, we just return 0. If not, we just use the map and reduce to get the sum of the capacity. Yeah. And for the other two balance, we use collect directly. Let's say the collect function. Yeah. First we get all cells, and then if this data is true, we just use the filter to filter all the cells with data. And if not, we filter all the data is empty. Yeah, it's empty is a function of the cell, which means if the data is 0x. And there is a detail here. We are collecting the cells from the indexer, which will the data format is basically the RPC data format. So when we create a new cell, we can use something like this. First, the capacity of the cell, we use a new amount with the capacity and a Shannon amount because all capacity amount from the RPC is a Shannon amount. And for the log script and text script, we just use the script.from RPC method to create an instance from the raw RPC data. And the same with the output. This can be very useful when you are interact with the RPC interface. Okay, when we finish with the balance and the unspent cells, we can now try to create, update, or delete the cells. First one, create. Create is very easy because we just need to set data to user defined value and then resize the cell. As we are creating new cells, so the input cells can be any unspent cells. No specific cells are needed. And for delete, it will be also very simple because we just need to set the data to 0x and keep the capacity. So we just need to use the input cell. Yeah, select the cell as the input cell and use the same cell as the output cell, but with the data set to 0x. And then we can just remove phi from the capacity, so the transaction is built. And the third one is update. First, we need to set data to user-defined value, and then reset the cell. Yeah, we have to use the selected cell and to change its data, and then change its size. We have to use the cell itself as an input, and possibly we need other cells because the data may be bigger or equal, be bigger than or equal to the original cell, right? So if it's bigger than the cell, we need more capacity, so we need other cells. If it's equal to the cell, we need to provide transaction fee, so we also need other cells. Okay, let's first say the cell assembly. Let's first assemble the cells. The function is here. It's all in this OP cell. Yeah. First, we define the input cell and the output cell as null objects, and then we say we depends on the model to do some to do different things. If the mode is delete or update, we need to set the input cell to this current cell, which means the selected cell. And the selected cell is looked like this. Yeah, let's first create one. Okay, transaction sent. Yeah, it's pending. So if this is the cell we are going to delete or update, when we click the button, it will be set to the current cell. So this means the selected cell. And we just set the selected cell's data to 0x. And then if the model is create or update, we need to create a new update output cell, right? Because for the delete mode, we only need the output cell is the input cell, but in the other two modes, the output cell should be created. So we just set a 100 value, a random value, and we just fill the data with the user defined data. If the data starts with 0x, then we use the cell.set hex data method. If not, which means it is the plain text, so we use the set data method. After we fill the data, we just invoke the resize method to get the capacity just to fit the cell's size. Okay, after we assemble the input cell and output cell, we can now use our builder. Inside the builder, we can see the actual logic of building the transaction. The first, we can let's say if we have the input cell. If the input cell is provided, then it means this is either delete mode or update mode. So we have to put the input cell into the inputs. And then we define a variable which is called needed amount. It means the amount that need to be fetched. So besides the amount of the input cells, how many amount we need to fetch from the the indexer. And we can talk about this later. Then we say if the input cell is presented. If not, which means we need to get all the capacity from unspent cells. So let's say if the needed amount has been provided, which means if this sentence is executed. If it is executed, we just add the value to the needed amount. If not, we just set it to the needed amount. And if there is input cell and also there is output cell, which means this is the update mode. Let's say if the input cell's capacity is less than the output cell's capacity. If the new cell is bigger than the old one, we need extra inputs. So we need to, just fill the needed amount to the output cell's capacity, subtract the input cell's capacity. Yeah. So let's say, this is a little complicated. Let's say the change cell. The change cell, first we set the change cell to the input cell. Because if we are in the delete mode, the input cell will be the only output cell. Yeah, so we just set the change cell to this one for the initial value. And if input needed amount is provided, which means we are in the create mode or update mode, we need to collect more aspect cells. And then we need to calculate the sum of the aspect cells. Once we got enough capacity, we just call the break. But the sense can be that we finished the whole loop and didn't get into this branch, which means the sum is less than or little than the needed amount. Then we will throw a error because all the capacity that can be used is not enough. Then we are using the input sum. This we are calculating the input sum. If the input cell is provided, we just add the input cell to the aspect cell's sum amount. If not, we just use the sum as the input sum. And then, as we are in the create or update mode, we need to create a new change cell. The capacity is the input sum substrate the output capacity. And if we are in the delete mode, this branch will not be executed. So to this branch will not be executed. So the change cell will still be the input cell. And at this point, we set the change cell as the only member of the output cell's array. And let's say if we have the output cell, which means this is in the create or update mode, we have to say if the change cell is big enough, because if it's not bigger than the 61 CKB amount, the transaction will fail. So we just add the change cell capacity into the output cell capacity, which means there will be no change cell anymore. The output will be the output cell will be the only cell in the output cells. So we just clear the output cell array and unshift this output cell into the array. Yeah, if this branch is not executed, the output cells will be the first element is the output cell and the second element is the change cell. Okay, after the whole bunch of cell manipulating, we come to the step of building the transaction. We can see the transaction accepts the raw transaction as the first argument, and the weakness arg array as the second one, and the weaknessless, which is also array as the second one. The third one, yeah, sorry. The raw transaction accepts the input cells and outputs. The both arguments are cell arrays. This is a big improvement from the old SDK, as that if the old SDK just requires the input, the cell input. The cell input is basically the outpoints of the input cell. The information of the input cell is limited because you only get the transaction hash and index of the cell. You don't know how big the cell is. You don't know any other information. So we improve the model to that all the inputs and outputs are all cell arrays. And this one, yeah, this arguments mainly defines the length of the witness, so you can just forget about it and just use this one as the default value. Yeah. So here comes to the fee part. Calculating transaction fee is very complicated in CKP development, because once you got the transaction fee, if the change cell is bigger than the transaction fee and is also bigger than the transaction fee and the mean change amount, which means it's bigger than the 61 add the transaction fee, then everything is fine. You can just assemble the transaction, right? But if it is not big enough, when you add the fee to the transaction, you need more cells for the transaction fee. Then you need to fetch another unspent cells here. But this will increase the inputs, the number of the inputs, and will also increase the total size of the transaction, which will also increase the transaction fee. So you have to, rebuild the whole transaction and calculate the new transaction fee and repeat the same procedure. So we just use this kind of solution, which is recursively called the build function. If the first time we didn't get it right, yeah, we got this, the fee added, the mean change is greater than the last cell's capacity. We just need to invoke the build function again, but passes the fee from this round to the next round. So we can see at the beginning of the function, we got the fee here, and if the fee is not now, yeah, if the fee is provided, we just set the initial value of needed amount to the fee. So it can, it will got the last round, the fee of the last round here, and then start from this capacity. Yeah, this will finally solve the fee problem. We call this fee convergence. Yeah, convergence. Yeah. So after we solve the fee problem, we just need to add the fee into the last cell, and the transaction is built. So this is not easy, right? But it's a lot easier with our builder, as we just only need to think about the cells instead of all other cell depths, header depths, a lot of things. Yeah. So let's say the builder. The builder have to has the main abstract method to be implemented, which is the build function. And it also has a static method called calcFee. This can calculate the transaction fee, and you only need to pass the transaction object. We need to write the sentence exactly like this because if we want to get the transaction fee from outside the builder, just like we need to display the transaction to the users, we can access the fee from this function, and the value from this function is set here. So when you implement your own builder, don't forget to set the fee to this member. Yeah, so you can get it out of the builder. And for the SDBuilder, we can see that we have a customized constructor with the input cell and the output cell. We have implement the build method, and with the logic like if the input cell is null, then it is create mode. Else, if the output cell is null, it is the delete mode. And else, which means input cell and output cell are all provided, it will be the update mode. And then we just mentioned the fee convert. Sorry, I need to check how to read this. Yeah, convergence. Okay, the fee convergence. We just need to recursively invoke the SDBuild function, which pass, but don't forget to pass the fee from this round. Okay, the final step, send transaction. This is very easy. Just use the SDBuild.send transaction and pass the SDBuilder and the ETH signer here. Then you will get the transaction hash. Whew, yeah, this is almost everything. We can see the cell we created, and we can try something like update. Let's play with it. Okay, so let's wait. And don't forget the README because there are really a lot of extra information here. And again, I recommend you to read through the source code, especially the source code for those models. Yeah, there are a lot of other abilities that I haven't covered this time. So let's see if it's down. No, it's not down yet. And we can just try to delete this one. Okay, this is all display bugs. I mean, when you delete the cell, the data will be empty, and when you refresh, it will come back. It's just the display bugs. Yeah, the first one succeed. You can see that the capacity increased to 177 CKBs, and the data is a lot of tests. Later we will see that the first cell disappeared. Okay, maybe not so fast. Yeah. And finally, thanks for listening. And one more thing that I want to show you is that we are not only try to enable the Ethereum wallets and not also not only the EOS wallets or Tron wallets. What we are really focused on is how to make the experience of our deck similar with the internet applications. So let's show you something amazing. We can see that this is the R1 demo.cqv.pw, and I want to concentrate that the next few steps. We can see there is a very long address which is surprisingly a valid CQV address, and it has a balance like almost 10,000 CKB. This is a DivNet CKB from our div chain. And after click this button, I will send 100 CKB to this address. So how to issue this transaction? I'm using the MacBook Air with Touch ID, and now the Chrome is asking me to put my finger on the Touch ID to sign this transaction. Yeah, okay, success. We have got the transaction hash. And to see this transaction, we are going to use our own transaction explorer. Yeah, this is a temporary div chain explorer. Yeah, we can see the almost 1 million blocks, and we are going to shut down this div chain soon because we see that Agron is kind of more stable than previous times. So if you are watching this video, a few days later, maybe this procedure will change to just see this one from the Agron Explorer. The benefit of Agron change to Agron is that you can just acquire the CKB from the Explorer, right? You can just use the explorer.novost.org//agron. Okay, let's say, yeah, the number changed. You can see the transaction here. So this is the valid transaction. Yeah, you can save it on the CKB Explorer. But I just issued the transaction with my finger from for the Touch ID and directly use the web page without any MetaMask or other things. Quite amazing, right? If you want to get this ability, the only thing you need to do is continuously to use PWCore for your DApp. As we make this better, we will integrate the ability into the PWCore, so your DApp will automatically get the ability to run like this. Yeah, if we after we immigrate this step to the Agron, you can just use this to get the test CKBs. So, okay, that's pretty much everything I want to show you today. If you have any questions, I'm on the Tech Support channel of the Hackathon. You can also, add me and talk to me privately if you have more complicated questions. I'm happy to answer them for you. Thanks again for choosing PWCore. See you next time. Bye.